So basically going to continue with a second component of the 2022 paper. So this is from study unit 6 to 11. So now one can look at things where we look at normal distributions. Again, you would see this was also asked in some of other papers and questions, where they give you some of the probabilities, and then you need to decide which one is correct, incorrect. So in this one, they want the incorrect one. So that is, again, remember, incorrect, that we don't make a mistake with, unfortunately, picking the first one that is correct. So normal distribution, at no exact point in a normal distribution is there probability. So probability that Z is exactly 0.4 is 0. Okay, so in a normal distribution, you can't have an exact probability for a point. Okay, so yes, we can go bigger, equal or bigger, equal or smaller, but no, there's no probability for an exact point in normal distribution.
Yeah. Do you like it?
Okay, and then if you look at the next one, where we say probability is Z bigger than 0.4. So let's say that is bigger than 0.4. Is that the same as this is the 2022 exam paper? So the second part of the 2022 exam paper. So they're bigger or equal, so 1 minus, so let's then say it is 1 minus, and let's get another color in, Z smaller or equal to. Okay, so if you say 1 minus the green component, you will get the orange component. So that is also correct. Okay, then let's draw another one. Z smaller than 0.4. So Z smaller than 0.4 is the same as Z bigger than minus 0.4. Okay, and that we know is all right because of symmetry, so happiness with that one. Then we go and check what is the probability of that Z. So the Z bigger than 0.4. So if you then go to your Z tables, and you look at that, your answer will be 0.33 or 3446. I unfortunately don't have that table now with me, but if you go to Z bigger than 0.4, so if you are going to look at this area that you're looking for, that is going to be 0.3446. Okay, and then the last one is to say, and we can do, let's do a graph here. Z smaller than 0.4, but bigger than minus 0.4. So that area, is that area the same than z smaller or equal to minus 4? Minus z bigger or equal to minus 4. Okay, so you can definitely see, let's use another color, sorry. So if you're going to take the red, subtract the orange, you're basically sitting with this component and that is not the same as the component in the middle. So that's why E is the incorrect option. Okay, so this one, unfortunately, not a quick way just to get to the answer. So very important here that one just work through the options to get to that. Yes, question.
Good day, sir. So
Uh,
my
yes.
question is, why do we get that 0.3446 only as negative 0.4 when we're looking at the Z table? So
Okay. So first thing is, if you look at the negative Z table, you're looking at that component. So then it would be 0, minus 0.4. Remember symmetry, what happens on the one side happens on the other side, so you can use that. But then if you want to get this from a positive table, you need to say 1 minus this probability that is at the 0.4. So this probability in the positive table is probably something like 0.63 or something like that. So to get to that 0.3446, you need to say 1 minus whatever then is for that positive 0.4, what the probability is. Okay. Does that make sense?
yeah, yes, sir.
Cool. Okay, awesome. Okay, let's go to the next one. Okay, so with your study unit 6, there's normally a question like that we now covered. There's normally a question like that because it looks at nearly, if you understand the symmetry, if you understand the smaller, the bigger. So there's always a question like that in the exam. Then they go into the next one is when you start using the formula. So where you need to start using Z is equal to X minus mean divided by standard deviation. Okay, so that is normally how they would then go to the next question around that. So let's look in this, what they give us. A random variable X is normally distributed with a mean of 85. So we've got the mean, standard deviation of 20. Calculate the probability that X, so that Z is at most 135. So at most can't be bigger than 135. Okay, so that is what we're gonna work out. Okay, so Z smaller or equal to, so 135 minus 85, I think it's 50 divided by, oh, no, that is still, just make sure, no, that is still, no, sorry, I wanted now to say square root. So that is what, 2.5. So the probability that Z is smaller than 2.5. Okay, so again, one can look at the tables. So first, what I notice is it's already bigger than 0.5. So let's look at answers bigger than 0.5. Okay, all of them bigger than 0.5, so that doesn't help. So negative, so you can look at the negative table and look at that portion that would have been on the negative table at minus 2.5. But that gives you just that small area. So that's not really what we want. So what we want is from the positive table, the value of the probability that it is smaller than 2.5. So here, if you use the negative table now, again, you would have needed to say 1 minus to get that bigger. So you could just go to the positive table and then read off what is the value at 2.5. And at 2.5, it will be something around 0.99. So where's the 0.9938? Okay. So this one, we didn't need to go to the negative table. Could have gone straight to the positive table. From the positive table, you can go into the answer automatically. Okay. So then normally what happens is they have a very similar type of question, but instead of giving you the Z or asking the Z, they ask something like you need to work out what X is. Okay, so let's just look at this one. I just want to see if I can make it at least a bit bigger. Okay. Okay, so an analytics company sampled 90 online meetings and found the meetings to have an average duration of 90 minutes with a standard deviation of 90 minutes. Sure, just 90, 90, 90. It is further known that the probability that the average meeting duration is longer than X is, okay, so they give us, so probability is 0.8531. Okay, so that they're giving to us. So the first thing I would look at is, okay, they telling me X bigger or equal to what it's going to be. So here is 0.5. So somewhere on this side will be something that this whole probability is equal to 0.8531. Okay, so what I would go and check is, okay, on the Z table, can I see something where it tells me it's 0,8531? And now you guys need to assist me here. So on the positive table, where it is 0,8531, what is the Z value? If anybody can
So the Z value seems to be 1.0, sir.
1.0.
Yeah.
Okay, so then check for me on the negative table where it is negative 1.0, if your Z is then 0,1469.
So our Z is, so at 0.0 is, so negative 1.0 on the side and 0.0 at the
Yes.
top, that is 0.1587. But 0.1469 can be found at 0.05 at the top.
Okay, so it's probably around 0.05 per answer. Okay. Does everybody else also get that?
So for the
Yes.
Z value for 0.8531, it's actually 1.05.
Okay, cool. So that's perfect. So that's why then the negative is for 0.14969 is minus 1.05. Okay, cool. So we working with this Z that is negative 1.05. Okay, because we wanted to see that smaller area. Okay, so we still have this wonderful formula, but never forget that we're still using this. We now just have the Z. Normally we would need to go and calculate the Z, but now we calculate the X. So it looks like the mean is 90. Then they tell us there's a sample, so that formula is divided by the square root of, so standard deviation is 90, and the sample is 90. Sure, there's lots of 90s. Okay, let's see if my calculator can, oh no, okay, okay, we're going to Excel. Okay, so I don't think my Excel is sharing, because I only have one screen, so it's definitely, I don't think it is sharing. So I'm just gonna work out a few things. So 90 divided by square root of 90 is 9,48. So if I say 90 divided square root of 90, which is 9,48, and I multiply it by minus 1.05, I get minus 9,969,96 is equal to X minus 90. So keep x on the one side, take the 90 over, so plus 90 minus that, so our answer is going to be something like 80,04, and depending on rounding off, okay, so it is 80,04, so at least I rounded it off there at the right stage. If there's 3 decimals, just continue. So also just look at your number of decimals to make it simpler when you work it out in the end. I think in the 2024 paper there was also a question like this. So what sometimes differ is here they gave us the sample information, but they could have given it to us in this format where we also needed to work out the x. So it doesn't need to be always in just the normal distribution. It can also be where we're referring to the sample normal distribution. And then normally after that, there is a question around proportions. Okay, so here they're asking, you get the proportion of 0,88. We've got a sample of 150. And you need to then, so this one you guys can check out. I'm not going to go through this one now, but you basically need to do the following. So that is where the 0,88 is going to be. So you need to test it between 0,83. So you need to get the Z value for this one. Then you need to get, here is 0,93. You need to get the Z value for this one. Then linked to this Z value, you need to get that probability. And linking to this Z, you will need to get that probability. And add the two together. So that is how you would go about this. So it's definitely going to be two separate calculations. Work out what this Z is with a 0,93 minus 0,88 divided by that standard error for proportion. On this side, it's going to be 0,83 minus 0,88 divided. And remember, for each Z, you will need to get a probability. So don't subtract the Z's and then get a probability for that. You need to work out the probability for the one Z and work out the probability for the other Z. Okay, so that's how you would manage this question around the proportions. Okay, let's go to the next one and see. So now, so that covers study unit 6 and 7. So we did this for study unit 6. We went into normal distribution study unit 6. Then the sample study unit 7. then proportion study unit 7. So then we go into confidence intervals. Okay, and you will see confidence interval for a mean and a confidence interval for proportion. So important thing is to first, as always, for the one that's with a mean, need to say, is it standard deviation known or unknown? Okay, so let's see a random sample of 60 individual items results in a sample mean of 200. The population standard deviation is known to be 100. Okay, cool. So we know that it is a population standard deviation, so we're working with a Z. Okay, working with a Z confidence interval of 95, so we can say that Z is going to be 1,96. So then you can say, how you're going to work it out, it's 200 plus minus or 1,96 times your standard deviation 100 divided by the square root of n, which is 60. Okay, and then you can go and solve this. But the important thing here was we need to identify standard deviation known or unknown. Here they tell us population standard deviation is known. So we're all cool with that. So then it makes it easier to use the Z. If it was unknown, then we would need to do a T. Then the T is degrees of freedom, and then alpha divided by 2. So then we would have needed to go to the T table where degrees of freedom is n minus 1. It would have been 59, and alpha would have been 0,05 divided by 2, so that would have been 0,025. And then whatever that t is, we would have just substituted it into the 1,96. So just that with this one is normally the big catch is around this question. I can't do it with a proportion because proportion is always a Z. So just be careful what they do with a population standard deviation. If they say it's known, or if they say, so the words that it would have been a T is a simple random sample of 60 items result in a sample mean of 200 and standard deviation of 100, or sample standard deviation of 100, or an unknown sample standard deviation of 100. Okay, so, but when they throw in population, cool, it's known. And they even said they didn't need to say population standard deviation is known to be. They could have just said population standard deviation is 100. And because it's population standard deviation, all cool, that you can use the Z. Okay. Then on
Sorry, sir, I have a question.
Yes.
On the previous.
Yes.
Yeah, I wanted to know, because normally when we are presented that small confidence interval table, there's always a two tail and one tail. Which one are we supposed to know, and how do we know which one we're supposed to use?
So for confidence intervals, it's always two tail. So confidence interval, because you're working, your mean is always between 2 points, it's always two-tail. Okay, so that is confidence intervals, always two-tail. It's only when we get to hypothesis testing that the way that the hypothesis is structured will show you if it's one or two-tail. Confidence interval, always two-tail. They might want sometimes to confuse you in the exam by only asking the upper confidence interval or the lower confidence interval. So sometimes they do that, but it's always calculated as both lower and upper, so it's always two-tail. Okay. So even with the proportion confidence interval, always two-tail. And so again, always two-tail. And something else that you guys can check, and it normally should work out like that, is the mean of 200 here will be in the middle of those answers. It just works like that. So in this, it always seems like if you add the 2 and you divide by 2, you will get 200. But that is just your mean will always be in the middle of those two. So just again, if there's some weird answers that one gets. Okay, so proportion, where they talk about the population proportion. So again, proportion is always Z. 95% Z is always 1,96. Okay, the 90% is always 1,645. And then the 99, I think that is, I think it's 99, it's 2,58 or something like that. The 99, I don't always remember that great, but I think it is 2,58 or something like that. So let's just cross that out. Okay, so yeah, exactly the same. We'll go and say, okay, what's the proportion? The proportion is 94 divided by the 100. So that is 0,94. And then to work out the confidence interval, 0,94 plus minus 1,96. And then instead of writing out that formula, we just multiply it by the standard error. I think it's something like this. Ugh, not always 100% sure if I don't have my tables with me, but I think that it looks something like that. But that is the standard error. And then if you work that out, you will get the correct answer. Okay, so that is the confidence intervals of your Z or T with a mean and your proportion. Then after that, normally you go into hypothesis testing. But yeah, so this one, they ask a bit differently. So here's now nowhere where there's normally, see, so nowhere here is the hypothesis about, they give you the hypothesis to say H0. So let's read this one. And let's see if I can make it again a bit bigger. Cool. And okay, Deneo Connect, a startup, would like to submit a proposal to Google considering expansion. As part of their market research, Denia Connect needs your assistance in testing the hypothesis that the average fiber internet cost in South Africa is less than 600. Okay, so there comes in the one tail or two tail. It's directional, it's smaller than, it's less than. So that is where your one tail comes in. Okay, a sample then is given, and the internet cost is 550, standard deviation. Okay, so then Z is equal to X minus me divided by that. Let's quickly see if I tell us less than. Okay, so first need to check if I'm not doing that right. The mean fiber internet cost is 550. Okay, so there I made a mistake. I'm already saying that, so this should be the other way around. Minus 600. Okay, so that helps you to write that out so that you can check it. So I just went the biggest first, but actually X is 550 minus 600 divided by standard deviation 220 divided by 70. Okay, so then at the top already, that is minus 50. So your answer is negative. Okay, so all of them is negative, so that didn't help. Okay, so now again, 220 divided by square root of, let me just quickly check. Again, unfortunately, don't have any calculators. I'm quickly using Excel. 1,90. So if I now, let me just quickly see, this was 26.29. Then I get my answer is minus 1,90. Okay, which is there. Okay, so what they could have asked you, and just be careful for that. So they give you all of this information. They could have said, we're testing at a 90% confidence interval or whatever. And then instead of test statistic, they could have asked you what's the value of a critical value. Okay, so they can give you all the information. Yeah, it's fine. You work out the T-stat, but they could have nearly like, we're going to do here, try and work, I think here we're going to try and work out the critical value, but they could have given you just a bit more information and you needed to work out the critical value, which you just read from a table. So if whenever they ask you to work out the critical value, that you get from the Z or the T table. Okay, so if I ask you a critical value, then Z or T table, you don't need to do this calculation. This is only for the test statistic. There was a hand, unless I actually now answered.
Excuse me, sir.
Yes.
Thank you so much. I just want to know where is 550 coming from, because I'm not seeing here, or maybe it's my screen that is not showing.
No, it was my screen that was a bit. So the 550 is coming from there. The
Okay.
mean internet cost is for 550. Oh, sorry, it's my screen. I tried to see how big I can go without cutting off everything, but that's where the 550 come from. Sorry. Yeah, it was hidden off screen.
Okay. Thank you, sir.
Cool. Okay, so let's look at this one, because this one was also a weird question for me. So a quality control manager would like to test at a 6% level of significance. Okay, so 6% is 94. Okay, we don't have that at all on a table. Okay, so if a prototype sensors of self-driving cars have average speed of that, 9 sensors, everything normally distributed, critical value. Okay, so now they want a critical value. So, and let's just check if it is 1 or 2 tail. Prototype of self-driving cars and found to have assume that the lifetime of sensors is normally distributed. Okay, so they want to test, basically they want to test if the lifespan is equal to 3. That's an average lifespan of more than, cool. There's more than 300. Okay, so 94%, we don't have that on any table. Okay, so, but look what they're giving us. So at the 95%, one tail, what is your critical value? So from that tables that you have in your study guide, 95, one tail, what is the critical value?
So that is 1.645.
Okay, cool. Okay. So if we go to 94%, it's going to be less than 1,645. So let's look at the answers. That is too big. Oh, there's one that's less. Too big, too big, too big. Okay, so we didn't need to know exactly what the 94 or 93% is. We just know that it is less than 1,645. So they will only give you one answer that is less than 1,645. They're not going to give you a 1,555, 1,51, 1,495. That's not what they wanted you to know. Is you have a critical value on a one tail at 95%. It's 1,645. That's standard. So if we test at 94%, it will be less than 1,645. So they will only give you one answer that is less than 1,645. If you want to go and check this on the Z table, you can, but that's not what they're expecting of you. But you can go and check. So this area should have been 94. Then there you add a 3% because this will be 3%. So you can go and check on the Z table where you have a 97%. Check what is the Z for 97%. I think it should be there, or 94%. I think it's going to be Z 94%. Sorry, not 97. That is if we're doing two-tail. Sorry. Z 94. So where under that curve, 94% is lying here. What is that? Because this is one tail, so this is going to be 6%. So if you go Z positive table, underneath that table, wherever it is 0.94, it probably will lie between 1.55 and 1.56. But it would be interesting to just hear what the answer is. Does anybody get it on the Z positive table where this whole area is 94% or 0.94? What is your Z value? Yeah, I think it's going to be between 1.56 and 1.55 and 1.56. Is that what you guys got? Okay.
Sorry, sir. On this
Yes.
95%, which table are we using? Where we got 1.645?
So that is in the study guide. Oh, does anybody have a page reference for that
That
table?
is 158, page 158.
Page 158. Page 158. There's a nice table there on one tail, two tail, 90, 95, and 99%.
158. I can't see 158 on my study guide. Which one?
I will also share that table again with some of my notes that I've made on our WhatsApp group. I'll do that as well, that you guys have that table at hand again.
Okay. All right. I thought you get it from critical values, the table for critical values.
So you can get the critical values from the big tables, or the 90, 95, and 99%, which is used in all the questions. It's summarized in one small table.
Okay, so it's better to share with us that table. I think
I'll do that. I'll share that summary notes of me on the WhatsApp group after this session. Then everybody have those notes again, just as reference again. Okay, cool. So one thing that they haven't asked here, and it might be in this question. No, so just also you would have picked up in this questionnaire, nowhere did they ask you to work out the standard error. Okay, so that might also be a question that they throw into study unit 7 or 8. So in this paper, there wasn't. Yes, I did share the formula sheet, but I will share that again tonight as well. The summary notes and the formula sheet, I will share both on our WhatsApp group tonight. I'll check if I can share it in this chat as well. So let's quickly, while we're doing that, let me quickly see if I can share it in the chat. Let's see if it allows me. The notes I'm going to okay, no, it does not allow me to attach something. So I will definitely share it in the WhatsApp group. Okay. In a random sample of 200, the sample proportion is 35%. You are required to test at the 5% level of significance if a true population proportion is equal to 30. Calculate the p-value for the test and choose the answer from the options below. Okay, so here basically you're going to work out the z, and with that z you're going to get to the z table to work out the p-value. Ooh, I'm now again not always 100% sure about. That's why I always use the formula sheet. I hope that is the right formula. But then you will get a z value. Okay, and we will get a z value that you can work out the p-value. Now the question is just what's important. Is it one or two tail? So random sample of 200, the sample proportion is you are required to test at a 5% level of significance if a true population proportion is equal to 50. Okay, so you're testing that. Okay, so that tells me it is two tails. So whatever this p-value is that you're going to get here, remember two tail. So for the negative, it's also there. So whatever your value is, you need to multiply it by 2. So what I got when I worked it out previously, let me quickly just check. Is I got that this value is 0.0618, and luckily there isn't an answer for you. But then if you multiply it by 2, you will see it is option A. So what happens a lot is that the 0.0618 is also an option. And then a lot of students pick it, but forgot that actually we're looking at hypothesis. They tell us it's equal. When they talk equal, equal means the other null, the alternative is not equal. So we sit with a two tail. If it's anything else, bigger, smaller, we're sitting with a one tail, but here we're sitting with a two tail. So whatever p-value you have, you need to multiply it by 2 because it is a two tail. Okay, so that's the important thing on question 9 was one tail or two tail. Okay, so let's consider contingency table. I say test at 1%. Which of the following statements is incorrect? Okay, so what I will first do is work out the degrees of freedom. The degrees of freedom is columns minus 1 or row minus 1, it doesn't matter, times the other one. So it is 5 minus 1 is 4, 3 minus 1, 4 minus 1 is 3. So degrees of freedom is 12, which is correct. I'm looking for the incorrect one. So already here, if you look at that, the critical value, we're looking at degrees of freedom and alpha. So we're not looking at, so that is written wrong. So even if it was swapped around, your degrees of freedom is 12 and not 20. Okay, so that one is definitely wrong. We need to write it chi-square is equal where the degrees of freedom and alpha. Okay, so that is, and alpha is 1. It's actually 1%. It's not alpha divided by 2 like it is with your t distribution. So it should have been chi-square, degrees of freedom 12, alpha is 1%. Okay, so that one is just totally wrong. It's not even that it's written in the right sequence. Both numbers in that brackets is also wrong. Okay, then they ask a bit of definitions also. If observed and the expected frequencies are the same for each cell, then the t-stat will be equal to 0. So we've seen that in a few assignment questions as well. The null hypothesis is always the one that are independent. And then you can go and look for the critical value. So where it is chi-square on that chi-square table, degrees of freedom 12, 1%, you will get to the 26,217. Okay, this is a bit now where you need to do a bit of work. So consider the following contingencies. Calculate the chi-square test required. Sure. Okay, so first you needed to work out this value. And then you need to say, now this is a long question. 75, whatever that block is, to the power of 2 divided by that block, then plus 60 minus 70.49 divide to the power of 2 divided by 70.49. And then you need to do all of it up until, so all of it, all of them up until the last one. That's 41 minus, what is it, 46.34 divided by 46.34. So this is actually a long question that you need to work out. I would have totally guessed this wrong. I would have gone nearly for the biggest number, but obviously when you start working out one, you will see it is actually small numbers. But this 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 normally would take you a few minutes. So, and there is really no shortcut in this. So I would not expect, again, something like this to be in your exam, because this was also when the exam was broken into two, so there was more time. So I will not expect something like this in your exam, that you need to work out so many. If there are, it will only be 2 or 3. It will not be 6. Yeah, still. So what I'm thinking they're gonna do is they rather would would it's I don't think it's gonna be more difficult. What I think they're gonna do is, in a question like this, they're probably gonna have you select 2 things to say what's the degrees of freedom, like we had in that previous exam paper with a drop down, and you pick 12, and then you have another question that says what's the critical value. That there's 1 or 2 of those. It's not going to be that now suddenly, because there's less questions, it is now you're getting a sample of 20. So it won't be now that. So it will rather be that the questions is like that previous one where you might have to select 2 things. So they could have here again give you this information, but then one of the questions could have been, what is that value? With a drop down of a few options. And a second question could have been, okay, but what is here your degrees of freedom? And they might even include a 10% and say, what is the critical value that you will test against? So it's not that it's going to be now suddenly that, oh, you've got more time, now you can do more difficult things. That's definitely not going to be the case. Okay, so yeah, that that's for me also the biggest thing about the exam that's linear, that you can't go back to previous questions and do that how you would have normally picked easier questions first, then go to the next one. I also don't like that. It's a bit, but at least it it is in the order of your study units. So study unit 1's questions first goes through up until study unit 11. Okay, so let's quickly look at these 2 again. Yeah, oof, I don't have my formula page with me, so I would probably would have gone here with something that we did last time, the one divided by the other one. Yeah, so, but let's look at question 12, that at least we don't need. So the following simple regression equation, and let's make it a bit bigger. So there's your formula. Which one of the following statements incorrect? Okay, so when 1,500 DynaCollect unlimited data subscribers are working remotely, the average data usage is estimated to be 22.5 gigabytes. Okay, so we want the incorrect one. So numbers of working remotely gives you, okay, so 15 times 1,500. So we just substitute in this formula that as X, and that gives you 22.5 gigabytes. Correct. Then we go to the next one. When 22,200 times 15, that gives you 53 gigabytes. Correct. When 1,800 times 15, that gives you 27. So that is the incorrect one. When no unlimited data subscribers are working, when it's 0, 15 times 0 is 0. There is a positive relationship between the number of unlimited data subscribers working remotely and the average. So what is in front of the 15 is a positive number. So it is going to be a positive relationship. They're not asking us what that relationship is, what the number is. We just want to know it's positive because there's a positive in front of a 15. That's why it is positive. Yeah, and by just having this information, y is equal to 15x, you can't work out your R or coefficient correlation or anything like that. Okay, and then the last one, I think, I can't remember this formula again. I will need to check on the formula page that I will send to you guys later. But basically, we're using the SST and the SSE formula to work out your coefficient of correlation. Okay, so they don't tell us here, but so we're going to work out the R square, and if we square root that, we can get a R. Okay, so that is just what we're going to do, and then check if these things, which one is correct and incorrect. Okay, so I will share this, I will share the notes, I will share the formula page as well, so that you guys have everything. Yeah, I'm also, unfortunately, where this is the linear and you can't go back. So also with that, just make very certain that you don't skip a question, because you can't. So if you look at a question and you really don't have a clue what to do, rather guess an answer, and then go to the next question. Don't skip a question because you can't go back. Okay, so if you're done with question 1, you go to question 2. Done with that, go to question 3. Don't. The first year this was done, there was a few students that unfortunately, like we normally want to do, you like to page through your paper and then see how the questions is, and they went through all the questions, and then it was okay, but now they're actually done and they can't go back to it. So very important, nearly don't do question, finish it, go to the next one. Okay, so yeah, so good luck, really good luck. WhatsApp is still open. Gonna chat on WhatsApp the next day or two still. I am going to keep the WhatsApp open on Friday, but that is just for things that goes wrong with the login, and if um, the the apps are giving you problems and things like that. So please just use it for that. So I will probably after half hour or so I will just then close it. But please, I am in contact with the lecturer on the WhatsApp group as well. So if there is things popping up, send me a WhatsApp that I can let the lecturer know. It might be that we then say, but send that lecturer WhatsApp number. I'll share that if needed, that you guys can be helped. Okay, so and it is normally with Iris. So also just please test Iris a few times that you make sure it is working. I think the lecturer also shared a link on my UNISA that you can go onto and test it. So just test it to make sure that it is working. Also, there's not suppose when you write the exam supposed to be a code. So that then means something with Iris is wrong. Gonna ask the lecturer in any case. There is normally a code that they will share, but that automatically means nearly that Iris is gonna flag your exam. So rather make sure that that is correctly installed and everything, that doesn't happen. But if it happens, we'll worry about that on Friday. We're not gonna stress about it now. Okay, so that is it, everyone. I will share the recordings and all the other notes and things with you that you have it at hand. And then good luck, but we'll definitely chat also on the group further until you write. Cool. Thanks, everyone. Have a wonderful evening and good luck with the last day or two of preparations. Cheers, everyone.
Sorry, sir.
Yes.
I want to ask, is it possible to have the hard copy of the study guide using it on an exam?
Yes. Yes.